All right. Today I want to go over in this video um, operations with functions. Um, so um, I'll present my screen so that you guys can see me right. We'll go to this one. All right. Hopefully you guys can watch me right. My little glove. Okay. So we have function notation. So we could say a function, f of x, and that kind of means y. Y for this particular function that we have named f. And to show that it's not an unknown number, it's an unknown expression that varies depending on what value of x has. We do function notation with f with parentheses of x. So you feed x as an input, and then f of x represents the output given the input x. So let's say we have x plus 3 as our function. And then let's say we have another function. Maybe I'll use a different color. I don't know if that'll help, but we'll do that. G of x is 2x minus 1. So we have two functions. Now, there's a couple things that we can do with this when we talk about operations with functions. There's kind of a couple ways that we can write them. One way is to say, this might get annoying, but f of x plus g of x. They may say, what is f of x plus g of x? Well, you would just say that that is equal to x plus 3, and then you can think of parentheses if you want, or you don't have to put the parentheses, plus 2x minus 1. So you just have the two expressions added together. All you really have to do at that point is combine like terms. So maybe I'll choose a different color. You have x and 2x, that makes 3x. And then 3 minus 1 makes 2. So you could say f of x plus g of x equals 3x plus 2. And that's all you have to do for that one. I could also say, what's f of x minus g of x? And that would be the x plus 3. Maybe I'll do the colors for you. Hopefully not colorblind. That's okay, though. Just trying to help a little bit with the colors. You don't really have to see the colors. Minus. And remember that the minus sign will distribute into the other term. So this would actually become x plus 3 minus 2x. And then the minus comes with it. So two minuses make a plus, plus 1. It actually, the minus flips the sign on all terms. So instead of a 2x, this becomes a minus 2x. Instead of a minus 1, this becomes a plus 1 because of the minus distributing, changing the signs of everything in the parentheses. So we get that. So we see that the difference of f and g is negative x, because 1 minus 2x is 1x minus 2x is, this is 1x. You can think of it that way. 1 minus 2 is minus 1x. And then 3 plus 1 is 4, which some people don't like having a minus in front. Which I don't care, but it's up to you. If you don't like the minus being out front, you could rearrange these. So you could say 4 minus x. Either way, those are both acceptable answers. So that's addition and subtraction with functions. Now, let me see if I can well, I'll just start new. Let's say I have two, well, I got to clear, how do I clear? This way. Now there's another way that you can write that. So instead of, so if f of x, I don't know what I said, was x plus 3, and g of x was 2x minus 1, you could write f of x plus g of x is equal to those things added together. Another way to write f of x plus g of x is to kind of show that the function is the function f plus the function g, and that makes a new function, which is a function of the variable x. So this way of writing it is actually equivalent to this. It just says f of x plus g of x, but here they kind of write where the functions get added together, and you write this thing as a sort of composite function, or a single function of x, which is the addition of f and g. That makes a new function, f plus g of x. So you'll see them written this way as well, where that just means add the functions, and it's a function of x. The new thing's also a function of x. You could call this h of x maybe, where h of x is f plus g of x. So those are two equivalent notations, and it works the same way. Those would both give you 3x plus 2. So you just combine the like terms, the x terms and the constant terms. So that's addition and subtraction. You could also have f minus g of x, and that's where you subtract them. So x minus 2x makes minus x, and 3 minus a negative 1 makes 4, positive 4. So you could also write it that way. So you'll see it written both ways in the homework that's coming up. That's just something to be aware of. And this is what we're talking about when we're talking about operations with functions. When we talk about operations, we mean addition, subtraction, multiplication, and division. Right now, we're holding off on division. That's kind of like a topic of its own that we'll get to when we do a little bit more with functions. That'll be a ways away, but right now we're just starting with addition, subtraction, and multiplication of functions. So to go over multiplication of functions, you'll have, let's say I have f of x is equal to, what did I say, x plus 3, and then g of x, again, was 2x minus 1. Well, what if, there's a couple ways I could write this. I could write f of x. You could either write the big X for times. That might get confusing with the way you write x. Sometimes they might write dot g of x. Again, you could also write them where you just write fg. That implies they're multiplied. When you write two letters next to each other, that implies that they're getting multiplied, of x. Those are the same way. Those are different ways of writing the same thing. The multiplication of f and g. So that would give you, maybe I'll do the colors again, where f was red, and g was blue, or teal. And then you just have to do FOIL, which is the first, the outside, the inside, and the last two. So that's the first, outside ones, inside ones, and then the last two, multiplied, where you add each multiplication. So 2x times x makes, there's a 2, and then there's x times x makes x squared. Then you have x times negative 1, that's just minus x. You have 2 times 3 times x, which is 6x. And then you have 3 times negative 1, which is minus 3. Now we can combine like terms here. So we could say that this product, f of g of x, is actually equal to, there's only one x squared term. there are two x terms, so I can combine like terms. 6 minus 1 is 5. And then I have a minus 3 term. And that would be the product of the two functions. So again, this and this mean multiplication of the function. And you would just FOIL it like this or whatever. I'll do another one of those. Let's say I have f of x equals 3x squared, where g of x is now going to be equal to x squared plus 3x minus 7. Okay, so what is f times g of x? Well, I can just write them out. I have 3x squared, and then I have x squared plus 3x minus 7. And then I'm going to distribute this term onto each of the other terms and just figure out what I have. So I will have 3 x squared times x squared makes x to the 4th. Then I have plus 3 times 3 makes 9. X squared times x makes x cubed. So I have 3 x's there. You just add the exponents, where this is like an exponent of 1. And then lastly, I have minus 7 times 3 is 21. And only an x squared here. No x's over here, so x squared. And that would be the product of those two functions. Now, I do notice something, that they have common factors, so I can pull those. You could simplify. This is correct, but if you wanted to simplify, or I don't know if should I simplify, if you just wanted to break it up a little bit, it's perfectly fine, just to show that you recognize that they share things in common. They each have, so you can think of this as 3 times x times x times x times x. And this is 3 times 3 times x times x times x. And this is 3 times 7 times x times x. So that's 21x squared at the right. 21x squared. This is 9x cubed, and this is 3x to the 4th. Now what I notice is that they each have 2 x's at least, and they each have a 3 at least. So I can pull out 3x squared from every, well, I guess I already have it in this form. You could pull out the 3x squared because they all share that in common. And then I guess you would get what you had before, the x squared, the 3x, and then the minus 7. I guess I'm not going to simplify it because I guess that's the way it was before we started. So there's really no point in undoing what you just did. But sometimes they're able to be factored in a different way than how you started. So you could refactor. But it's kind of pointless in this case, sorry. Anyway, but that's how the multiplication works. You just take one times the other, distribute the terms depending on how many you have, and that would be your how you do those. I'll do one more. Let's say you have f of x is equal to 2x minus 1. And now g of x will be equal to x squared plus x minus 1, just to keep things simple. So let's say I want the product of f of x times g of x, which again could be written f times g of x. Same thing. Well, that's going to be 2x minus 1 times x squared plus x minus 1. So to do this, I am going to distribute this onto each of the terms, and then I will distribute this onto each of the terms, and that's going to give me 6, 2 terms by 3 terms. That'll make 6. I should have 6 terms. So I'll have 2x times x squared. That'll be 2x cubed. And then I will have 2x times x, so that's 2x squared. Then I'll have 2x minus times minus 1, so that's minus 2x. And then for the bottom set, I'll have minus 1 times x squared, so I have minus x squared. Then I will have minus 1 times x, so that'll be minus x. And I have minus 1 times minus 1, which is plus 1. So I should see that I have 2 x squared terms, and I have 2 x terms, and then I have an individual constant term, and then I have an individual x cubed term. So I will have 2x cubed. That's like the only term I have. For the x squared terms, I have a 2 and a minus 1, so that'll just make a 1. For the x terms, I have a minus 2 and a minus 1, that makes a minus 3x. And then for my constant term, I just have a plus 1. So altogether, this is my product, and that's how you do it if you have a binomial times a trinomial. That's 2 terms and 3 terms. You'll get 6 terms, but you'll be able to combine like terms. So it came down to 4 terms. And you can kind of tell what the leading term is going to be. It's going to be a cube because this leading term was an x to the 1, and this leading term was x to the 2. So the leading term, when you multiply them, should be an x to the 3. So you can know that to expect that. I think that's pretty good for the sum of functions. Now, one thing you might get is a table or a graph. So let's say I have a graph that says at 1, 2, 3. Let's say my one graph is like this. Let's say it's like, so this is like, here it's at like 1/2. Here it's at 1. And here it's at, well, that shouldn't be the case. I should say at 3, it should be at 1.5. So that's one function. This is f, let's say. And then I have another function, g, which will look like 1, 2, 3. And then let's say it looks like, let's say it looks like this, where it's goes maybe 3 goes to 2, goes to 1, goes to 0. So this is here, and then this is at 0 at 3. So this is, well, we're not going to say what the functions are, but they could ask you with a graph like this, what is f plus g of x? Or maybe not x, but let's say of a specific x value, let's say 2. So let's say, what are these functions added together at 2? Well, I'm going to look at where f is at 2. Well, let me say that this is equivalent to f at 2 plus g at 2. That's the same thing. So I just got to figure out what f of 2 is. F at 2 is 1. And then what is g at 2? G at 2 is also 1. So that's 1 plus 1. That's going to make 2. So you can go off the graph when they ask for specific x values, not just an expression, but what are the things at this particular value? You can just plug them in. So that's how you can do that with the graph. Just say f at 2 is 1, and g at 2 is 1, so they're both 1. So add them together, that makes 2. Now you could get expressions like, let's say f of x is 3x, g of x is, I don't know, x minus 3. What is f plus g at 1? Okay, so that's the same as f of 1 plus g of 1. So I could, I could do this. I could say 3x plus x makes 4x minus 3. I could figure that out and then plug in 1 here and say, okay, that's going to be 4 minus 3 is 1. So I could find my answer that way, where I added the expressions and then plugged in to the new expression. Alternatively, I could say, well, f at 1 is 3, and g at 1 is minus 2. So if I add 3 and minus 2, I get 1. So either way you want to do those. If they ask for a specific value, you just plug it in, and then you can add those after the fact, after you plug them in, or you could add the expressions first and then plug it in at the end. Either way works for these operations with functions. It'd work the same if you said, what is f times g at, let's say, 6? That's the same as f at 6 times g at 6. So what is f at 6? Well, I plug in 6 times 3, I get 18, times, what is g at 6? I put in 6 minus 3, I get 3. So I'd have to multiply 18 and 3. Well, I guess I can do that in my head. So I get 30, 3 and 8 is 24, so 54. I'll check that real quick. So I suck at simple math. Yeah, 54. So that's the way you can do those when they ask for a specific x value instead of just leaving it as x. One last thing, they might give you a table. So they might say, here's x, here's f of x, and here's g of x. 0, 1, 2, 3, 4. And then let's say f is like minus 2, we'll add 3, 1, add 3, 4, add 3, 7, add 3, 10. And let's say this one is like 6 minus 2 is 4, minus 2 is 2, minus 2 is 0, minus 2 is minus 2. So whatever, we got a couple lines there. And then they might say, well, what is f plus g of, let's say, 4? What is that? Well, that's f of 4 plus g of 4. So all I got to do is say, well, what's f of 4? X of 4, f of 4 is 10. And at g of 4, that's minus 2. So this, when I add them at 4, it should give me 8. So you can do that with a table as well as with a graph. And that's pretty much all there is to operations with functions. You just got to, just knowing that these things are equivalent and understanding that the thing in the parentheses represents the input, whereas the function on the input represents the output itself. So f of 4 represents 10, because that's f of x when x is 4, that's 10. So the input is 4, and this itself is 10. That f of 4 means 10. You think of it as a function, but when you put a specific number in for x, f of that number is itself a number. It's no longer a function. Once you plug something in, a function, you input a number, it outputs a number. So once you input a number, it's a number. It's the output. So hopefully that makes sense. The other thing is just to know that when you see f plus g, it's as one single function of a number or of a variable. That just means take them separate. Just take them and add them together. So hopefully that's not too confusing. Anyway, that's the lesson for this practice assignment. I hope that all makes sense.